Yes, welcome back to Easy Gates, Gate 22, Easy memory based questions. So let us get into the next problem. It is also from analog electronics. Another problem using an operation amplifier. The problem is very simple. So there is a capacitor in the circuit and he's asking the difference between the maximum and minimum value of the voltage VC. Okay, the capacitor voltage only the problem. And you remember the circuit, it is a astable multi-vibrator. And you know the capacitor is going to charge only between the UTP and LTP. Okay, so if you bring that idea into the play, the problem is getting over instantly. But he is surprised as yes, the designer has surprised us by giving two ideal diodes as well. Ideal diodes, see that's a characteristics given for the diodes. So let us play. Okay, so it's all about how the capacitor is going to charge. If you play for the voltage across the capacitor VC of T, it is the one responsible to trigger your entire circuit. So this is going to be the potential. So if we take VC of T, then the VC of T in the given circuit will be something like this. So there will be a UTP, there will be a LTP. It is going to charge from LTP to UTP and then discharge from UTP to LTP. This is what going to get repeated. Okay, depending on your output. If you plot your output, when the output is positive, it is going to charge. This is the output, and when the output is negative, it is going to discharge. Okay. So what is the output given? Maximum is plus 50. Minimum is minus 50. So let me take it this way. So this is my output waveform between plus 15 and minus 50. So we should know when the capacitor charges, when the capacitor discharges. With this, the problem is going to be very easy. Yes, what is that? LTP, we need to find out LTP. We need to find out this VLTP and this will be VUTP. It's asking only that, the peak to peak of that. So you have to find quickly this gap only. So that's a maximum and minimum values of VC. This is a VC max and this is the VC minimum. Usually UTP will be because of plus 15 and LTP will be because of minus 12. In this case, usually by habit, you will go for plus 15 and minus 15. See in the problem, he played for minus 12. So answer will change because of that. Okay. Yes, now let us play for the UTP. Yes, so let me assume the output of op-amp is at positive saturation. Assumption here is VD is positive. That's what it means. So this is plus 15. Let me take a different color. Yes. So the output is plus 15. So plus 15 means, let me call this as a diode 1. This diode is D2. So diode 1 is going to be in reverse bias. So it is off. And D2 is going to be in forward bias. It is on. Because of forward bias, ideal diode, this is going to act as a short. Okay. So means that whatever the current exists, it is going through the diode. So no potential drop across this resistor. Okay. That will help for our calculation of the potential at V plus. Whatever the potential at V plus, that is going to be your VUTP. Upper triggering point voltage. Till that, the capacitor will charge. Okay. After that, what will happen? Because this voltage is going to be a positive potential, the capacitor will charge. By the time the capacitor voltage increases beyond this, then VD will trigger the output because VD is switching from positive to negative. Therefore, V0 also will switch from positive to negative. Okay. Yes. So when the switching happens at the UTP. Yes. What is the UTP? We'll find that quickly. So this is 15. So 15 means this is off. Then it's R, and another R in the play. So therefore, the current is going to be 15 divided by 3. R will be the current. The same current is going through the diode T2 and then going through this. So it is going to be 15 by 3 R will make a drop across this as 15 by 3 R into R. It is going to be 15 by 3. It is going to be 5 volt. Left side is 0 volt. Therefore, this is going to be 5 volt. And no drop across the diode. This is 5. Therefore, this is 5 volt. Therefore, the upper triggering point is equal to 5 volt. Okay, so the capacitor can charge only up to this 5 by the time it is exceeding triggering happens. Okay, yes, next point, we'll find out LTP. For that, you take output as minus 12. So assume the output is now switched to minus 12. Because of that, this is minus 12. Already we have given the label. This is D1. This is label D2. Okay. So now who will be on? D1 will on because it is sensing negative potential, but D2 will go off because anode will sense the negative potential. Assuming this, so there is no current. It is almost like an open circuit, and this is like a short circuit. This is short. So therefore, this resistor is shorted out, and therefore this point will be minus 12. So then this point is equal to 0. So the net drop is going to be, so current is going to be from 0 to minus 12. That's your current. So the current is going to be, what is that? 12 volt divided by, again, you will get 3R. So 12 by 3R is a current that is going to make a drop across this. What is the drop? It is a 2R. So because whatever the current comes, it is going through this way and no current, confirming why D2 is in reverse bias, it is in cutoff. Okay, now this I into 2R will be the voltage across this. So 12 volt divided by 3R into that 2R will be the voltage. That is equal to, it is 12. So RR will get cancelled. 12 by 3, there is going to be 8 volt means. So this is 0. From 0, you are losing 8. Therefore, this point will be minus 8. So that means the capacitor already charged to what? Plus 5. It has to discharge to minus 8. By the time it is crossing minus 8, again VD will become positive. We'll switch the output from minus 12 to plus 15. That's very important. But anyway, the problem is over. This is your LTP. So VLTP is equal to minus 8. Therefore, the capacitor peak to peak. That's a peak to peak. That's a maximum to minimum difference. It is nothing but 5 volt is the UTP. Minus of minus 8 will be the peak to peak. That's a maximum. Okay, maximum to minimum difference. That is nothing but 13 volt. So the correct answer for this problem is 13. Okay, hope many has given this because it's an easy problem. Because problem lies in finding only the upper triggering point and lower triggering point of this astable multivibrator. Okay, yes, you should know it's an astable multivibrator. Then all the fundamentals should be brought into the play. Then you can complete the problem instantly. Okay, yes. So we'll update you with one more problem soon. Do subscribe our channel and also share to your friends. Thank you.